So today we're going to be reviewing electric circuits. You've learned this in grade 9 on how to draw circuits and all the circuit symbols and stuff like that. So the first basic definition of electricity is what is a circuit. A circuit has to be a closed path where electrons can flow. And there are three basic components. Every time there is a circuit, you must have a source, and you must have a load, and you must have some sort of connector. Okay, so those are the three essential components of a circuit. Additional thing could be a switch, could be a fuels, could be a voltmeter and other stuff. Those are optionals, but in order for a circuit to allow electron to flow, you have to have these three things. And we have been learning this, and we're going to do this time again is circuit diagram. So we're going to be drawing circuit using standard symbols. Another way to call these types of circuit is sometimes we call it the schematic. Schematic diagrams. So basically using standard symbols that everybody understands. Like instead of drawing the entire light bulb, we just use a little symbol to represent that, and we're going to talk about that. Okay, so these are the symbols. If you want to pause this and actually start doing this on your own, you should be able to fill out most of it. But I'm just going to go ahead and do that. And just now we already talked about the first thing is that you have a sources. It could be any one of these sources. It could be having your battery, your rechargeable battery, or a AA battery, or plugged into a wall. Your circuit have to have a source. Okay, and then the symbol for an electric cell is you would have a short line and a long line, and then it's connecting to the wire, and you must label a plus and a minus. The shorter line is the negative terminal, and the longer line is the plus. Okay, the next one's a 3-cell battery, similar to an electric cell, but this time they tell you it's 3 of them, so you make 3 sets of them, so long and short. So there's my 3 sets. I label my plus and minus, so minus is always the shorter one, and then I connect it to the rest of the circuit. Okay, an AC power supply is now plugging into the wall. We have alternate current. Okay, it's almost like a stop sign shape with almost like a sine curve, a wiggly line. Okay, a variable DC power, it's almost like a stop sign, but it has like an opening at the top. See how the top doesn't close all the way? You still have this little wavy line thing, and then you have a line. I forgot to label these. These you still have to put a plus and minus terminal. That's why when you plug into your battery, it matters which way you put it. Okay, the next ones are the conductors. So the second thing that you have to have is it has to have some sort of conductor. Mostly are wires. If you have a smaller thing like a motherboard in your computer, sometimes they put soldering and liquid metals, and when they melt it, it becomes a conductor. That could also be called as a conductor. But we're just going to use wires in here, so a straight line. Control device are optional, but we still use them. So an open switch is you draw a line and you put 2 dots around them, and you make it so that it's not touching. A closed switch is one line with the 2 dots, and you connect them up. Okay, and the closed and the open switch is actually when the circuit is off. Your light bulb is not going to work. The circuit is not a complete loop because you open it up, cut the electricity is not a complete loop. But on the other hand, a closed circuit is the on one. So you hooked it up, you turn the switch so that it's on, and it's called a closed circuit. Okay, a lamp. We're now moving on to loads. Loads are electrical appliances that convert the electricity into some other form of energy. Say, for example, a lamp will convert electricity to radiant as well as thermal, right? Heat and light. Electrical motors convert electricity into kinetic energy, right? It's going to start turning, and then a resistor turns it into heat. Okay, so a lamp is being drawn like this. So an easy way to draw it's almost like if you draw a cursive. Just erase this. So I can draw almost like a cursive E, a little loop, and you put a circle around it. A better looking light bulb can be something like this with a circle. It's up to you. I'm totally okay if you just do the letter E. Okay, electrical motor, big circle with a capital M, and a resistor, which we will use a lot in this course. Just saying whatever the load is, it has a certain resistance. We'll be talking about that later on as well. Okay, the next things are the meters. The meters are measurements. They do measurements. And ammeter, it's a circle with the capital A. Voltmeter, it's with a V. Okay, I don't know if you remember these. You learned these in grade 9. Okay, in an ammeter, measure the amperes. Do you remember what quantities is being measured with the unit of amperes? It's the current. Okay, so this one actually measure how much current is flowing through. A voltmeter measure volts, so it's actually measuring the voltage. And I'm going to quiz you to remember another word that is the same as saying voltage. Voltage can also be said as a potential difference. Okay, and the rule for connecting these devices are, we will talk about these later on too, but an ammeter, it always connected in series. Is it a word? Like, you should have watched the video just now, so you should know what a series and a parallel circuit is. So a series, so it's actually one after another. So if I were to hook up an ammeter, I actually have to hook it up in series with a light bulb or something like that. Okay, a voltmeter is always connected in parallel. And an ohm meters are also connected in parallel. Ohm meter is used to measure ohms. Do you remember what quantities measure ohms in ohms? Okay, is your resistance. Okay, and an ohm meter has a symbol. It's not an O. Don't put an O. It's actually a little horseshoe. Do you remember it? Omega? Okay, so it's a Greek symbol omega, and that's the shape of an ohm meter. All right, so we briefly mentioned this, but let's just write the definition down. A series circuit is when there's only one path for electron to flow. They are connected end to end. So it's like one big complete loop, okay? On the other hand, a parallel circuit, they would have their loads connecting by branch so that there are two or more paths for electron to flow. Okay, let's do some example here. Please use a ruler, okay? And what I do is I suggest that I'm just gonna do a little thing at the side. Like, this is what I would normally do, is that I would start off my circuit drawing like a rectangle. These are like a general rules, okay? It might be different, okay? And in general, I like to put my source kind of on the left hand side and my loads kind of at the right hand side, and then I put either the switch at the top or the bottom or any meters. So that's how you start. You always start off with the main path first. People like in grade 9, they always forget that, oh, if I need the loads in parallel, I still need the one main branch to have at least one load before I branch off. Okay, so in here, question number 1, asking you to draw a series circuit with a 3-cell battery, an open switch, and 2 lights. So in series means they're all one after another. So I'm just gonna draw my template first. Sorry. Okay, so I'm just gonna draw my little box to start off with. You don't have to do it every time. I'm just doing it at the beginning just to make sure we're good. So I'm gonna use a blue pen. Okay, so they tell me that I have a 3-cell battery. I'm gonna put my battery somewhere over here. So 3-cell battery, so 1, 2, and 3. So short and long. Don't forget to label your plus and minus. I have an open switch, so I'm just gonna put my switch at the bottom. An open switch means the 2 dot, and then I do a line that's not connecting it. And then I have 2 lights in series. So I'm following the rule here. I'm gonna put my loads to the right hand side. So I'm gonna draw 2 light bulbs in series. So they're all along the same path. I'm gonna put a circle around them. And I'm gonna connect up the rest of the circuit. Right, so I need to put in my wires in between all of these guys. Okay, I don't know if I can erase it. Oh, no, I don't want this. Okay, let's take this guy. I'm gonna move these guys out of the way so they don't make it hard to see. I'm gonna take these little dotted line. And do you see my circuit looks something like that? Okay, I'm gonna take this guy out too. Okay, so that's what it is. You don't have to do the dotted line thing. The dotted line is just my way of showing if I were to change this in grade 9, I would totally start with that. Okay, but I think some of you already really know how to do this. Okay, so next thing, I'm gonna move on. Number 2. Draw a circuit with a variable DC power supply, 3 motors wired in parallel, each with their own open switch. Okay, so a DC power supply, I'm going to draw it on the left hand side. So it has, I'm going to turn it sideways. So the stop sign thing, a little wiggly line, my plus and minus. In this one, I don't know which one is plus, which one is minus. Okay, and then they tell me that I have 3 motors. So I have to start off with 1 motor. I know each motor has a switch, right? And I have 3 of them and they're all in parallel. So meaning my first branch, I'm gonna have my motor first, but it's hooked up to a switch. Okay, notice I'm closing this up. This is the main branch. Remember I said a circuit has to have a source. This is the source, right? That's the source. It has to have a load and it has to have the wire. Okay, so when that's established, then what you do now is you can now branch it off. When it's something that is in parallel, meaning I'm going to create an extra branch. So I'm going to go out this way. Going to do another motors that are in parallel. And then another motor that is in parallel. Okay, so does that look like something you would draw? There is a misconception. Okay, I'm gonna explain it now because you guys are in 3U, you're gonna be studying the circuit. Some people will feel that the current, okay, current always leaves from the negative, okay, will come in here. At this point, will split in 2 paths and then split again in here. And then split again in here. It doesn't happen like that. It actually all comes in and split into the 3 paths equally. So a really proper way to draw the circuit diagram, if you truly understand what a parallel circuit is, I'm going to redraw this for you. Both ways will be marked correct. But later on when you actually study this, you know, the voltage and the current and stuff like that, in mentally, I need to understand it as this way. So I have a power supply. Sorry, my ugly drawing. Okay, what really happened is that you actually have this 1 point and it's split into the 3 like this. Okay, so I'm actually going to draw in my motor. And each of them have a switch. And they join back in like that. Does that make sense? This is actually a more proper way of understanding how a parallel circuit is. The current just go all into the 3 paths. Okay, so the definition of a parallel circuit is you can actually go into the different paths, right? Okay, last one. Pause this video, draw it on your own first, and then check my answers. I have a 3-cell battery, 3 resistors wired in parallel with each other. Each have their own open switch, a light in series with the battery, and then an open switch to control the entire circuit. 3-cell battery. Short is minus, plus is the long, and they each have 3 resistors in parallel. And they each have their own open switch. And then I have a light bulb in series with the battery. So that means with the battery, I have another light bulb, either at the top or the bottom. as long as it's just in series with the battery. And then I have an open switch that control the entire circuit. See, I'm going to close this up. Okay, here's the part that I struggle. Some of you might draw a picture that is very similar, but maybe off. Some of you might look like something that's totally not the same, but it works. I'm not sure if I can have enough scenario to tell you, you know, this might be okay, this might not be, but I'm going to try to play with variety right now. Okay, there are different ways you can draw these. Okay, so I'm going to show you. Okay, so some of you might have drawn the light bulb up here and the switch up here, which is totally fine. Okay, so this is okay. As long as it's along the main path. This is the main path. These are in series, right? Anything along the red are in series. So your battery, your light bulb, and switch, as long as they lie on the red part, anywhere, no matter what order, it's fine. Okay. The only thing that is not fine, well, there are maybe other ways too. I don't know if I'm missing it. Some of you might draw it like that, and then you would have your light bulb and your thing going here, and then thinking that that's in, and then your parallel resistor. This one is no good, okay? Because that, when you connect it like that, you've actually turned it into a parallel. So right now, your battery is actually parallel to the light bulb. Okay, so you cannot do that. So this is not good. Okay, another one that is common mistake is sometimes people put an extra line like this before they branch it off to the parallel. Grade 9 do that a lot. Okay, if you put that there, you've just created a short circuit. Definition of short circuit is when you have a battery and there's no loads. Okay, so the currents are going to go so fast, you're going to heat it up, and a lot of accidents are caused by a circuit that has zero loads. Because what happened is all the current is only going to want to go through this red wire, because this red wire will have the least resistance. The currents are going to go the fastest in the red wire, and so by choices, the electrons will want to go onto this this line, and it'll get overheat. Okay, so make sure you don't create a short circuit by putting an extra wire that is there that is not needed.